Where's your microphone?
You're talking into it, don't worry.
Where is it?
Which number did you say? No, it's on the...
Justice for Johnny.
What? So this is that quadratic form that we can do again, right? You know what I'm talking about? All right, so what multiplies to 16x to the fourth but adds to negative 17x squared? Negative 16x squared and negative 1x squared. Because when it's even, no you're not. When it's even, half, and constant, you can do it like normal. So then it would be, yeah. When it's even, half of the, so even, half, constant. No, I'm just supposed to put on a little show form. No, not at all. So now I'm ready to slash. What's the GCF of the first two? X squared. What's left when you take x squared out? 16. Middle sign stays. 1. This is number, I don't know. So now I have x squared minus 16, x squared minus 1. I don't have to fully factor this. Did it say factor or did it say solve? Oh, so I do. Oh, okay. So, jealous. I plan on new stuff today. I plan on a review of some old stuff. All right, so here, x equals plus or minus 4, x equals plus or minus 1. That's it. I'm going to multiply the first and the last together. 7. Charlie Ray, what two things multiply to 4x squared but add negative 5x squared? Four and 1, negative 4, negative 1. Good job. What can you take out of the first two? Bigger, 4x squared. What's left? Middle sign stays, can't take anything out, x squared minus 1. I got some difference of two squares here. I got x squared minus 1. I've got 4x squared minus 1. And I could continue to factor it down if I wanted to. I could do x minus 1, x plus 1. Or I could leave it like this and solve it. It doesn't really matter. So I get x equals plus or minus 1, x equals plus or minus 1/2. Yes. What else on your homework? Yeah, so these would all have multiplicity of 1. Yeah. 16. Every one of those goes through. All right, so I can take a GCF out here first, right? X to the third. Leaves me with x squared plus 16x plus 64. And then I'm going to factor this. That's a PST, yes? Part square trinomial. It's square Nances. So I can do x cubed, x plus 8 squared. If you slashed it, you get the same thing. So x squared plus 8x plus 8x plus 64. Slash it, you come back to the same thing. So what did it ask you for? Multiplicity and stuff? Yeah. So x equals 0 would be this one. What's the multiplicity here? Y'all can do this. 3. That's okay. So what does it do? Through. What's the other solution? Multiplicity, it bounces. That's right, because it's even. You really need them? It's just multiplicity 1, and it goes through. All right, let me review you quickly on what I got for you today, because we're going to use this to do some factor remainder theorem. It's kind of new, but it's not new. Okay. I bet y'all remember this. You may remember it and you may not need to. Long and synthetic polynomial. Sorry. Y'all don't remember polynomial division? Polynomial division, both long division and synthetic division. Yeah. 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 No. You makes me eat what? Yeah, I'm a customer. Okay. So it's coming around to you. I'm gonna do number 8 first for long division. So it's 4x cubed minus 23x minus 21 divided by 2x plus 3. Remember, you need placeholders, right? I just keep saying mom spaghetti. All right, what do I mean when I say placeholder? I need a 0, but where do I put a placeholder? You never pay attention to anything. All right, so I need a placeholder. I start, Charlie Ray, with the biggest exponent, and I need to make sure I have that exponent and everything down below it down to the constant, right? So since I started with a 3 here, then I need to make sure I've got a 2, a 1, and a constant, yes? I'm missing the what? The 2, that's why I put a 0x second, right? Thank you, Clay. Ever so kind. So when I set this up, I'm just going to go with it. What I'm dividing by goes on the outside. Yeah. It has been. It'll all come together. We don't do actual calculus.
Oh no, I didn't even get this last year.
We have to, in calculus, we have many problems that we have to do long division or synthetic division in order to get it. And so if we don't put it in here, never get it. In between, so because I start with the biggest exponent, I have to have that exponent and everything down below it. Yes. Yeah. All right, what do I multiply 2x by to get 4x cubed? 2x squared. Yes. Long division. We did this, and this is just a review of Algebra 2 stuff. In fact, this came Algebra 2, but this is not anything new, so don't wig out on me. We'll get to Descartes' rule of signs tomorrow and other stuff like that, and that is new. So you put it, so what do I have to multiply 2x by to get 4x cubed? 2x squared. So I go to the squared column and I put 2x squared. And then I multiply around. Is this coming back to y'all? Do you remember doing it? 2x squared times 2x is what? And 2x squared times 3. Just like regular long division, I subtract this whole thing. The first one should cancel. And then I get 0x squared minus 6x squared, which is what? Same step with regular long division that I do now. Drop down the next term. Now what? That's right. 2x times what gives you negative 6x squared? Negative 3x. And now multiply around. Same process. There's so much repetition here that you can't help but remember it when you start doing it. So negative 3x times 2x is negative 3x times 3. And I'm subtracting all of that. Yes. So it's negative 23 minus negative 9. So negative what? 16? 14. You had me second guess on myself, too. Drop down the next one. Somebody said 7. You're really close. Negative 7. Multiply around. Negative 14x minus 21. Oh, nice job, Delaney. No remainder. They will not all be no remainder, but what does it mean to not have a remainder? Or, well, actually, no does. Okay. What if I did have a remainder? What if I'd gone through all this? That's exactly right. I would come here and say plus. If I got a number here, I would do that number over everything on the outside, or would I divide it by here? And that's how I would write that remainder. Now, that's not hard, but it's long. What? They're not all long division. Because we learned a shortcut. Yes. So when can I use synthetic, which is the shortcut? That's just when I have x plus some number or x minus some number. No exponent, no coefficient. Yes. Sorry. Yeah. Well, because whenever you subtract here, you get 0. All right, let's see if you remember. We'll just look at number 1. Now notice the directions. The directions here do not say simply divide. They say use synthetic division to factor, which is leading us up to some things that we're going to get to here real soon. So if I divide, let's divide first, and then we'll talk about what we're going to do. So on the outside goes the opposite sign here, and I can do synthetic here because it's just x minus a number, right? So I put the 2 outside. What goes inside here? 1, negative 5, negative 12. And in fact, it's all these coefficients, right? All right, now be very careful because, again, if I need a placeholder, I need to make sure I throw it in here. All right? Now the process of division comes. A lot easier than the other. Drop the first term. What now? Multiply and add. Multiply and add. Multiply and add. Why would I do what? Because it's just x minus a number. All right, so this is x squared minus 3x minus 18. Remember, we count down from the right, this being the remainder, the constant x squared. If we had another column, it'd be x to the third, and so on and so forth. So,
Hold on. Slow down. How did you get to -6?
so you drop the first one, multiply by what's on the outside, multiply, and then you add the column. Yep. Y'all don't remember this? Negative 5 plus 2 is -3. You start with the last column and it goes remainder, constant, x squared, x to the third, x to the fourth, x to the fifth. You count up. Well, you start with remainder. You start far right, remainder, constant, x squared, or x plus something, yeah. Okay, so now, yeah. Yes. All right, so this question asked me to factor by dividing the polynomial. So what that means is this actually equals, I can use what, since there's no remainder, right? This means that x minus 2 times the answer that I got, x squared minus 3x minus 18. This is just another way to write that original problem, okay? Just like 6 divided by 2 is 3, I could write 6 equals 2 times 3. It's just another way to write it. So this times this. And now I could finish factoring, right? How does that factor? And remember, we did this, and then we rolled into PRZs, because if you weren't given the factor to start with, so we'll refresh all that a little bit. Clearly, we need to refresh more than what I thought we did. Okay.
That's it.